welcome.
Thank you very much for the introduction. So, as he said, my name is Esther David, and I am from Ashkelon Academic College. Ashkelon is located somewhere in the middle between Tel Aviv and Beersheba that Tammy was describing. In this talk, I would like to refer to some future AI globalization economic challenges that I view that are going to be very fundamental. I will start with I will start with describing a bit some of the projects we have done with collaboration with the NTU ST. So in 2013 until 2015, we collaborated with the support of the MOST of Israel and Taiwan with Professor Lee and Professor Kenneth that is going to talk later today. And in this collaboration, we worked on developing new anomaly detection algorithms. And after a very successful collaboration on this project, we won another collaboration from the Ministry of Science and in 2015 and 2017, and this project was about cybersecurity and IoT, and we had Professor Xi Ming and Su Jin that are not here today. And actually, the collaboration was very successful, and we also had some student delegation exchange. Our students are coming here this summer for the 4th time for the Intel summer internship, and they are very excited about that. From the day they enter our department, they're asking, are we going also to go to Taiwan? This is the first question. We also had a delegation of master students from the NTU ST to our college, and here you see this guy there. He gave some tutorial to our students, teaching them how to use the IoT technology that they brought with them to Israel. Okay, so let's start. So in this talk, I would like to consider 3 challenges. The first one is a globalized job matching system. The second one is developing a mechanism design for self-driving systems. The first 2 challenges are basically based on game theory and mechanism design. And the third challenge is energy efficiency using AI and the IoT technology. This is mostly based on machine learning and deep learning. So let's start with the first challenge of developing a globalized job matching system. So let's start with defining what is a job market first. So a job market is a market in which employers search for employees and employees search for jobs. So now I will review some facts that will motivate the challenge of building and developing a job matching market. So according to some report in the US, 71% of workers admit to active job searching job searching, or at least there are openness to new opportunity. So that means there are many people are constantly searching for jobs. The second fact is that due to the AI development recently, there are going to be 50 million people that are expected to lose their job by 2025. And they will be replaced by smart machines. So this is also try to state that there are going to be a lot of people that will search for jobs. Moreover, in the near future, and we already see it today, a massive amount of jobs are going to be performed virtually. So that means that we can think about a globalized job matching system that will be able to match workers and employees all over the world and actually want to do it automatically. One example of such a virtual job is worker that monitor CCTV surveillance videos around the world. And we are all aware that there are cities that are completely covered with CCTV cameras, and actually no one is looking at these videos. So I guess in the near future we would like to have workers that will look and do the surveillance work. So regarding the globalized job matching, so it's not that there isn't any companies that are dealing with this today. There are many job companies that you will find on the web, but they have some disadvantages. First of all, the matching is not done automatically. That means that still there is a lot of work of matching a person using interviews, some tests, and some other things in order to match a certain worker to a job. A second disadvantage is that work seekers have incentive to lie about their capabilities, okay? Because it's a virtual world, they can do that. And third is that the employers also have incentive to lie by describing high benefits. So in conclusion, what we get from this job matching is that no efficient allocation is reached. We want to reach an efficient allocation where worker and jobs are matched optimally. So, in general, our aim is to develop a job exchange market that satisfies the following properties. First of all, we would like all the participants to have and to use a truth-telling equilibrium strategy, meaning they don't have something better to do rather than saying the truth about their capabilities or the benefits from the employer side. Secondly, we would like to reach an optimal matching that will maximize the general welfare. Again, it's from a global view. That's what we want to reach. Third, we would like the mechanism to automatically determine the wages of the assigned worker. That will relieve the employees from trying to calculate what wage they need to offer. So we find a lot of similarity between this job exchange market and the advertising ad exchange, as so-called ad exchange. And the similarity is as follows. So first of all, let's look at the ad exchange. What do we have in an ad exchange? In an ad exchange, we have two types of players. The first type, we term them the publishers. The publishers are actually entities that have a website on the web, and they are willing to dedicate certain space on their web page for advertisement in order to get some reward for that. On the other hand, we have advertisers. The advertisers are interested in showing their ads on different web pages. In the middle between these two groups of players, we have the mediators. And there are many companies that do this mediation, and they are called ad exchanges. We have, for example, the DoubleClick of Google, or the Right Media of Yahoo, and there are many more. So the analogy between the ad exchange market and the job market, as we see it, is as follows. we think that the employees in the job market, they act in a very similar duty as the publishers, in the sense that as the publishers are looking, they have some preference about what advertisers they want to be shown on their webpage. The employees have preferences about which worker they want for their job. On the other side, the advertisers are analog to the work or the job seekers. Okay, they want to get the advertiser want to get the ad exposed, and the worker seeker want to get the job. The main similarity between these two type of players is that in the ad exchange, each publisher has a different value for the different ads. And similarly, in the job market, each employee has a different value for each job seeker. And because of this property, that there isn't any fixed value for showing an ad, or there is no fixed value for hiring a person for a certain job, and what will be the wage for him, this all problem should be solved by mechanism design. And for the ad exchange market, in our previous work, we proposed weighted VCG plus a Hungarian algorithm for optimal allocation that satisfies the following properties. First, we proved that the ad placement achieved by this algorithm is efficient, in the sense that it maximizes the general welfare. The second property is that it's individually rational, meaning that all participants are guaranteed that they will not lose anything by participating in this market. The third property, strategy proof, means that all participants have a truth-telling, even dominant strategy, meaning they have no incentive to deviate from the truth-telling strategy. And this is a very, very strong property that mechanism designer would like to have for their mechanism, because that means that the participant will not have to speculate or to work in order to place a bid or participate in the market. Third, and also very important, is computational efficiency. So our proposed algorithm has a quadratic complexity, and it's very important because in the ad exchange or in the global job matching market, we expect to have a lot of participants, and therefore the computational complexity is very important. Besides these properties, we were able to show that the algorithm we proposed is also budget balanced. So if someone who looks at this and say, okay, what do you mean by you have a mechanism that it is a budget balance, so what new about it? And the new thing about it is that, I'll skip this, that the original mechanism that we are based on, which is termed the VCG mechanism, is efficient, is individual rational, is strategy proof, but he is not budget balance. And being not budget balance means that sometimes the amount of income may be less than the amount of charges or payment that the system will have to do, meaning that the mechanism manager will remain with deficit. In order to show that, to express that, we will see an example. So I'll show you how basically the original VCG mechanism works. So maybe first I'll explain that the VCG mechanism is very strong by being strategy-proof and everything. The disadvantage of being not budget balanced actually prevents this mechanism from being used. Okay, so we are very familiar with many other auctions, like the English auction, the second price, first price auction, but we're not familiar with the VCG. So if it's so good, why don't we see it? So the problem is that it is not budget balanced. In the VCG mechanism, there are two stages. In the first stage, we calculate the optimal allocations. Once we have the optimal allocation, in the next stage, we calculate the payment that each of the participants will have to get or pay to the system. And the payment goes as follows. The payment of player I will be the result of the difference between the total value of the optimal outcome, assuming player R is absent, is not in the system, minus the total value of the other players from the chosen outcome, assuming I is present. If it looks complicated, let's consider the following example. Assume we have a university president that is interested in improving the student welfare by building for them one of the following buildings. Or building for them a swimming pool, or a gymnastic room, or a restaurant. So the president goes to the student and asks them, what do you prefer? Please declare your utility for each of these options. So assume the following example, where we have the first student declaring utility of 1 from the restaurant, 3 from the gymnastic room, and 10 from the pool. And similarly the others. So according to the VCG, we would like to choose the option that maximizes the general welfare. So to do that, we sum the utility, the total utility for each of the options, and we see that the pool has the greatest utility, and therefore the pool will be built. So the second stage of the VCG mechanism here is to calculate how much each of the students will have to pay for building this pool. So the payment calculation goes as follows. In order to calculate the payment for this student, we will have to assume that he is not in the system. And once we take him out of the system, we need again to calculate what is the optimal allocation, but without this player. And in this case, it will be building the gymnastic room. And the value for that is 10. Okay? And so the payment will be this 10 minus the value of the option that was the pool when consider all the players, but without this value. So this is 7. So the payment that this student will have to pay is 10 minus 7, which is 3. Okay? So for example, in the second case, we have, let's assume that the blue student is not in the system. The value of the all options will be as follows. And here, even if the blue student is not here, building the pool is the best option. So we will continue to, we'll take this option, and it will be 17 minus 17, because this is the value also when he is not there. And this player will have to pay only 0. Okay, similarly, the other two will have to pay 0 to the system, and the system in total will end by having only a payment of 3 from the first student. So this is an example where we get only 3 for the system, but the system didn't go into a deficit. Next, let's consider an example where the system does go into a deficit. So for this example, assume that we have three players that propose to build something for the student. We have the university that proposes a restaurant, the government that proposes a gymnastic room, and the city council that proposes a swimming pool. Once we will have to consider that one of the players is absent, then in that case we will also have to assume that the option that he's providing to the system is not cannot be considered. So let's assume the following example. So we have the university, the government, the city council, and we have the student aggregated value for each of the options. So here, when we see minus 40, that means that the university is prepared to build a restaurant, and she is declaring that the cost will be 40. The government is willing to pay a gymnastic room, and she thinks that it will cost her 50. Okay, and similarly. So we want to apply a VCG mechanism. So the first stage is to calculate the optimal allocation, just by summing the utility for each of the options. So by looking at that, we understand again that the pool will be built because it's 50 relative to 30 and 10. So now let's consider the payment that the university will have to pay. So when the university is not there, so there is no option for building a restaurant. So we'll have to check only the other two options. So for the gymnastic room, we have 30, and for the pool, we have 50. So the price that this player will have to pay will be 50 minus 50, which is 0. Okay, these players act similarly. Okay. In this case, the city council, what it will have to pay is when he's not there, the only two options that are available is the restaurant and the gymnastic room. And the gymnastic room is better because it has a utility of 30. So when he is absent, the value is 30, minus 100, which is the value of the pool when the city council is not there. So this means that the city council will receive the minus 70 means that the city council will receive payment of 70. However, the student, using the same calculation, will have to pay only 10. So the system ends up with a total of minus 60. So that means that the mechanism manager will have to pay to the city council 70. He will get only 10 from the student, and he will remain with a 60 deficit. Okay, so now that we have understand a bit the mechanism, the VCG, in our previous work, and I won't go into detail, but we did some adjustment using a weighted VCG, such that we were able to avoid the disadvantage of being not budget balanced, and our proposed mechanism is budget balanced. Also, he saved all the other good properties, and we're able to overcome the one disadvantage of this mechanism. So, given this background about the advertising mechanism, we would like to, and we believe that the VCG mechanism can also be a great solution for the job exchange. And the only problem or challenge that we are in view is that instead of asking the participant, for example, the work seeker, to indicate what are their capabilities, we would like some reputation mechanism that will be objective and will determine the profile for each of the participants in a way that will be trusted. So we want to generate trusted value for worker and also trusted value for the employee. To do so, we propose to have an indirect sources of information, meaning we are not going to ask the participant to describe his capability, but we want to use other sources of information that will indicate his capabilities. For example, we can check the diplomas that he has, the age, experience, capability, from other sources, for example, from educational and academic institution, or using some banks and financial institutions. This is more for the employers. So using these various sources of information, we aim in building a dynamic, up-to-date profile for each of the participants that will contribute to the job exchange market to be trusted, efficient, and all participants will have truth-telling strategy. In order to make value of all these data, we propose to apply deep learning to create information out of all this amount of data. Second challenge I would like to consider, and we think that has a lot of similarity to the ad exchange and the job exchange, is the self-driving system. Assume we have a self-driving system in a sense that no human is driving anymore. Only machine gonna be the driving on the road. So what we envision is that instead of having a reactive attitude that we use today in order to drive on the road, we ask the Waze or any application which road is better for us to use. Instead of that, we will to have or to use an active attitude that in advance will balance the load on the road such that we will avoid traffic jams. The challenges in this case will have, so for example, I would like to plan a trip that containing driving on several parts of different roads. Then I will have to ask the mechanism for a combinatorial. We'll have to use a combinatorial auction because the participant is not requiring a specific road, but a combination of roads. Of course, we'll also have to apply some shorter paths and other techniques. But in general, we think that the mechanism design using the VCG can also be a very good solution for the self-driving system. Finally, I would like to shortly refer to another project that is the energy efficiency. And just to give some figures, Israel is aiming in saving 70% by 2030. The European Union is aiming in 30%. The USA is aiming in 40 or 60% saving by 2050. So there are many directions of efficiency saving around the world. Mostly they are in two aspects. One is improving the equipment and appliance, and the other one is the revolution or in the building design. What these two attitudes have in common is that they require investment. So here we propose to use AI and IoT technology for energy saving with almost no investment. Skip that. So actually, what we are focusing on is monitoring academic areas for saving energy in air conditioning. And we do so by a very simple idea. We assume that in class, the number of people is somehow equivalent to the number of MAC address that the Wi-Fi can detect. So we have a certain control in the class that using the Wi-Fi will collect the data about the MAC address in the class. And by that, the system will know how many people there are in the room currently. And by knowing this, the system can calculate what is the required consumption from the chillers in order to cool the room to a certain determined temperature. And similarly, when the control system will detect that the class is empty, so no matter that we forgot to turn off the air condition, now the smart system will know that no one is there. Of course, there are some challenges because we are using Wi-Fi. It means that the Wi-Fi will be able to detect also not only the people in class, but the system will also detect persons that are walking around the classrooms. So, but then we can calculate using the distance from the control system how far they are from there, and then we can determine whether if they are in class or out of the class. Okay, so based on this idea, we believe that substantial saving is expected and almost with no investment. So we can do much more with much less. Thank you very much. Question?
Yeah, I think we're a bit run out of time, so
Okay.
so maybe we'll send the speaker again, and after the next speaker, we have a 30-minute break. So at that time, I think we can have a offline discussion.
Yeah,
Okay,
thank you very much.
Yep.
Bye-bye.